your globe's imaginations are contaminated by the globe matrix. Yeah, globe's imaginations are not what I would personally call imaginations. I think everything is limited what they're allowed to think. They can't get outside of their limited imagination. So yeah, they can't see what's happening. Bart, Cyril, Apollo vid brought me to flat Earth research. Okay, Bart, Cyril, so probably he's done some good work. Bart, Cyril on Coast to Coast. Debut of Apollo photography nationwide. 37. Nice. We'll watch this little 6-minute video then. Who's that linked by? Gil. Gil2727 linked as a video by Bart Cyril. And he's exposing the Illuminati, exposing the Apollo fault flags. So I'll link that so you guys can do the live on YouTube if you want. It's like it's got a good cause. Metropolitan Police terrorist attack. I'm going to skip past that because I don't like to resonate on any level. I still want to know how Sybil got the footage exactly. Is he the guy that got that footage where it shows the lights turn on in the spacecraft, basically? That footage converted me to, convinced me that they're fake that they landed. I'm going to catch up with these comments here. Guess we need to keep a watch on the North Pole. Yeah, this is meant to be a big magnetic mountain in there as well, isn't it? That sounds cool. Mixlex says you'll pull out something. Yeah, Mixlex, feel free, if there's no rush, feel free to email me. There's my email address. If you've got a couple of good links you want to send that way.
Hello everybody, if you can hear me, let me know. Great, trying to keep up with the wrench adding here as you guys are stumbling in. Loud and clear. Sometimes people say I don't talk loud enough. I've heard that before. Maybe a bit more volume. Well, let's see how I can do that. No ball. Okay, is this louder? It's probably so loud you can hear the air conditioning in the background. I'm guessing most of you people are in Europe or the East Coast. It's 4 a.m. where I'm at currently. Thanks everybody for stopping by. I'll try to give you wrenches if I catch you. Alright, what should we talk about today? What kind of topic are you guys wanting to hear about? What can we tell the kids about flat Earth? You know, that's a really good question. oftentimes it's, as an adult, you have a responsibility to shape and mold the minds of young children. And whether or not you grow up in a religious household or an atheistic household, beliefs do get transferred from the parental or the authority figures in the house, for sure. However, my personal view on telling kids about the earth being flat is I ask them to use their senses, to go out and explore the world around them. Look at shapes, look at the horizon, look at what water does, and things like that. Allow them to come to their own conclusions. They will get indoctrinated in school, there's no doubt about that. However, I think if your children are smart enough, you can explain to them that there's two types of learning, and maybe even suggest that, not everything is wrong, because you don't want them to be contrarian in school. Sometimes children need to understand that it's okay to be one way at school and another way at home, because nobody wants to set their kids up for shame and ridicule when they get in the classroom. And until there is scientific evidence the other direction and the pendulum is swung into the realm of flat earth as being the true shape of the earth, it's going to be an uphill battle. And realistically, if there wasn't a globe in every classroom, they wouldn't know. You'd ask them, what shape is the earth? And they'd think it was flat. It's just kind of a natural knowing. But there's also a way to explain and understand things that children seem to grasp far better and far easier than adults do. So allow them to come to their own conclusions on that, but warn them that, there are going to be people that are going to tell you things that might not feel normal, like the earth is a globe. And they'll have all these reasons as to why it's a globe. But always ask them to trust their senses first and foremost, because your senses are always right, especially children. Children are empaths. Children are naturally intuitive. Children naturally pick up on things. They're more imaginative. And I think that's also one reason why educators are able to reach children and convince them it's a ball, because it is imaginative. And they do have Star Wars and space movies to back up the visuals. So, it will be an uphill battle, for sure. Evolvement says, I think that's the sore spot of the issue, holding two belief systems according to settings and circumstances. I am smart enough to know how to apply the when in Rome, do as the Romans do technique. I know how to fit in, where to fit in. I know how to mirror and model those people who are around me, either professionally or personally. When you shake a person's hand and you get to know them in the first 5 minutes of meeting, you know what language to use. You know how to present yourself in a way that makes them feel at ease and not off-putting. At least I do. I don't know. Maybe not everybody does. But it is a skill, I would imagine. But it is important to not be sucked into a belief that there's only one answer. There's only one solution. There's only one way to be in any one particular setting. There's always a way to circumvent social issues and navigate political issues, navigate the way, I tell my kids, look, school's bullshit, waste of time, but you have to put in the time. That's the rules for the society we're set in. You put in your 18 years and you're done. You don't ever have to open another textbook as long as you live. So just get through it. And quite honestly, no one's ever asked to see my diploma. No one's ever asked to see my grades. It's never really been an issue. What's been an issue is my ability to, say, for instance, interview, or my ability to communicate with others or work in a group, social things. Those are far more important than anything you'll learn in a textbook. So telling kids that, you only have to, well, let's take, for instance, rote style testing, or learning. They literally are just teaching for the test. And it's evident in the fact that kids will study and cram for finals, but don't have to need or retain that information once it's done. You can tell them the same thing about the ball. They only have to pretend that the Earth is a globe and learn the solar system model while they're in school. But in the real world, it doesn't matter. No one's ever going to ask them what the 8th planet is, right? No one's going to ask them how many thousands of miles away is the sun to the Earth. It's not relevant in day-to-day life. Yeah, if you've got grown kids and they think you're crazy, then just be the crazy old cat lady who thinks the Earth is flat. Doesn't matter. If it makes you feel better and makes you able to sleep at night, then just do that. Yeah, Hollywood is definitely far more powerful in shaping the minds of the youth than any school can ever do. It's sanctioned indoctrination via entertainment, edutainment. And it's all done on purpose. It's subtle. It's not an accident. Yeah, the Apollo hoax opens your minds up to other possibilities. That's what's great about the time period we live right now, is the fact that we have YouTube. We have crowdsourced information age where everybody is putting up information all at once. Anything is searchable. So if you want to find information that validates the Earth as a globe, the information is there. If you want information that validates NASA as a bunch of liars and fraudsters and tricksters, the information is there. So realistically, you can show any evidence that you want of any particular thing. Star Wars is fantastic. I'm telling you, the visuals from 1977 were very believable. And I find it odd that the visuals from the 80s shuttle program sucked. It's like, why was NASA not able to get great space? Why didn't they just contract with Industrial Light and Magic and say, hey, make us a space program? Why didn't they hire those people? Heck, in 1967, 68 it was, 2001 Space Odyssey came out. There's some compelling evidence right there that we can make space look far more realistic with rudimentary technology in special effects. Yeah, NASA is currently working with augmented reality. They've got some really fascinating stuff that they openly talk about, like the augmented reality contact lenses. An astronaut will put these augmented reality contact lenses in his eyes, and it literally allows him to see an object that's put in to the video feed, but it's not real. So he can interact with 3D models that are in real time that are not physically in front of him, but they're on the monitor, they're on the screen. And that's what they're doing. That's you can. I would say it's probably about 90% believable at this point visually. But if you watch some of the newer ISS footage where they're standing there and they're interacting with things floating and moving around, it's just slightly too crisp in comparison to their hand. And so they're using real 3D mapped models, but the interaction with them is just a little too clumsy. It's close. I mean, it'll fool a classroom of third graders who think they're talking to astronauts, that's for sure. Yeah, Mars is going to be fairly easy to fake. It's really easy to do. I mean, even if you did a live Mars feed, you could easily have an active filter within your processing equipment to put that red haze on things and to squash out any green or blue sky. So, but if they do it in terms of, they sent back packets of footage, that it's not live, then they could easily have the time they need to run the footage through post-processing and grading and get the color just right. And it'll be universal, so no matter where they are on Earth, if they're filming in the Atacama Desert or they're filming in Devon Island in northern Canada or in the outback, they can make it all look uniform. Yeah, the Mars project will be the show to prove next generations, absolutely, and we need to be on top of that right away. We need to find every chink in their armor. We need ham radio operators. We need people that have the ability to find where these radio signals are coming from, triangulate their positions, go to places where we suspect they are, fly drones, or just recreate the landscapes. Go out in the middle of the desert and recreate exactly what they're doing, scene for scene, shot for shot, and put them on YouTube, but don't say it's fake. Just put it up and show this is more Mars evidence, because at some point somebody will come along and question it, and then they'll have to question the Mars footage too. If just some regular schmo made it to Mars, it's just as convincible, it's just as conceivable as Mars. Yeah, some of the Mars rover footage is in Canada, some of it's in Ireland, some of it's in the Atacama Desert, some of it's in Australia. NASA has bases all over the place. They've even got Mars footage from Mauna Kea in Hawaii. So one of the things I've really wanted to work on was, before the Mars project kicks into high gear, I want to release an app for people's cell phones where they can take pictures with their cell phones and make it look like they're on Mars, so they can have family pictures and on each, but it just strips the image of the colors and dulls it down and adds dust and red to everything and makes it look like you're on Mars. Call the app Marsify. In fact, if you go and look at my channel videos, you'll see you'll see a video there called Marsify This, how I showed just how easy it is to make an image look like it belongs on Mars. And in fact, I downloaded an original NASA photo of the Mars rover, and I just ran it through Photoshop's auto color correct, and it actually made the sky blue again, which was really weird. I was not expecting that. I probably should have focused on that a little more. I know in the video that transition happened a little too quick. Perhaps I'll revisit that. I should probably take some road trips since I'm out here in the middle of the desert anyway, and take pictures and do some Mars scenery things. Put up some fake rover footage. People would believe it. People believe anything if you spruce it up with fancy graphics and claim you're an authority on the subject, like NASA does. Because why would NASA lie? In fact, I guess I can do this right here. Let's add a new window. Browser.
Free yourself from the frustration of remembering and resetting passwords. LastPass, it gets you in, like right now.
Ads.
Fake being on Mars. I'll make this one pretty quick, as this has been covered on lots of people's channels. But here's a picture of
dream of a close-up look at what it's like on another planet and of searching for life there today became a reality. And what a reality.
It's been more than 40 years since the Viking 1 landed on Mars and sent back the first images from the red planet. Since then, NASA has successfully operated 6 other unmanned landing craft and vehicles on the Martian surface.
Here is a new experience in excitement, a new sensation in suspense, as men open the door of the unknown powers of space to learn the incredible secrets of the red planet Mars.
Mars from the surface. Man's age-old dream of a close-up look at what it's like on another planet and of searching for life there today became a reality. And what a reality.
It's been more than 40 years since the Viking 1 landed on Mars and sent back the first images from the red planet. Since then, NASA has successfully operated 6 other unmanned landing craft and vehicles on the Martian surface.
This week, the space agency debuted its next-generation Mars rover, set to be launched in 2020. But now we're getting a look at what a future manned Mars rover might look like. Omar Villafranca took it for a spin at the Kennedy Space Center.
With 6 wheels and a distinctive alien design, tourists at the Kennedy Space Center Visitor Complex have no idea what to make of this extraterrestrial machine.
We saw y'all driving in our release. Well, that's the reaction that we like, right?
This is a new Mars rover concept vehicle, standing 11 feet tall, 24 feet long, and 13 feet wide.
What takes longer, your design or you putting it together?
The giant rover is the brainchild of the Parker brothers, Shannon and Mark. The two made their names in Hollywood, designing and building movie props, most notably the futuristic motorcycles in the movie Tron.
So no doors on Mars, you have to get into it through the back.
Right. Shannon designed the rover. Mark and his team did the dirty work, constructing the whole thing in less than 5 months.
There is almost nothing on this vehicle that was not built in our shop. I mean, down to every little bracket and tab. Nothing was ordered out of a catalog. We built the body, the chassis, the suspension, the wheels, the frame, the interior, the seats, the glass, everything on this vehicle had to be built completely from scratch.
Some of this was just for design, you know, just for it to look cool. Other things I thought, you know, this is kind of important to have.
I'm being very delicate with it, but this is the speed you would end up going on Mars. You're not flying.
You're not excited about the inside of the rover seats 4 and drives like an SUV. But there's also a mock lab in the back where astronauts could conceivably conduct experiments. Some of the features were designed with exploration in mind.
So we needed a good surface area for the rock to climb over, but then we needed a lot of surface area so when you get into the sand, it's not going to sink, but it also has these vents in it so it's not going to clog up. So it can go through really deep sand, not get stuck, and not get clogged up all at the same time.
The brothers consulted with astronauts when building the machine, but this vehicle won't go to Mars. Instead, it's on an Earthbound mission to educate future scientists about the red planet.
You really believe that?
Yeah,
those are
I
the
really
ones.
do believe that.
U.S. astronaut John McBride flew 2 space shuttle missions and says putting the first person on Mars is closer than we think.
Yeah, we think that the first man or woman on Mars is somewhere between 8 and 18 years old as we speak.
Right now.
So these guys are in the 3rd, 4th, 5th grade up through somewhere in college or after.
The folks at the KSC Visitor Complex hope the attraction will generate enthusiasm like in 2012 when the unmanned Curiosity rover landed on Mars.
Is public enthusiasm about it, does that have any bearing on what is decided in Washington?
I think it has a lot of bearing. I was congressional director for NASA, and people say, well, you ought to write your congressman, but very few people do that.
The eye-grabbing rover goes on display at the Kennedy Space Center's Journey to Mars exhibit starting June 5th. Omar Villafranca, CBS This Morning Saturday at the Kennedy Space Center in Central Florida. In Hollywood, designing and building movie props, movie props, movie props, movie props, movie props.
Holy, it knocked their head off. Oh, Lewis is dead.
I guess it doesn't look great if I crawl in there.
I wanna go to Mars.
Anyway, as you can see, they've openly admitting they're indoctrinating the next generation of kids to think how amazing and how great space is, because not only will they be future employees of NASA, but even if they never join the NASA team, they'll be more than likely to vote for budget increases, and they'll publicly be behind missions to Mars. And realistically, there's no reason to go to Mars. You know, we can say to explore other worlds beyond our own, but we haven't even mastered our own Earth. You know, we're more than half the planet doesn't have fresh water on a daily basis, yet we're going to send some people off to a far off land for billions and billions of dollars. Yeah, I find that's misprioritizing, you know, our resources and our tech. No, that rover obviously won't go to Mars, but they built it as a prop to excite people and to reinvigorate a new generation about Mars. You know, in 1972, when we stopped going to the moon, was because it was for bad television ratings. People got upset that the moon landing was cutting into their TV shows. It was just like, yeah, we went to the moon. Great. Can I get back to I Love Lucy? So that's why NASA has a strong publicity arm, a strong press arm. They have like a direct feed into the Associated Press. So anything from space.com, from NASA, you know, always gets top billing to fulfill any science and technology stories. So whatever they decide to come up with, whether they found a new habitable planet within the Goldilocks zone, or they've got some artist renderings of what that might look like, you know, they'll just pump that into a feed on a weekly, daily, monthly basis. Keeps them relevant, keeps them in the taxpayer's mind. Exactly. Only a fool would sit in one of those rocket bombs and expect to get to Mars alive. Even if we do send people somewhere. You know what's really great is we've kind of been fueling the public's imagination with the idea of going to Mars anyway with all these survivor shows, right? So you can literally just blindfold some people. Like, for instance, that fake NASA show that they filmed in the UK, and they flew them around on an airplane and took them to this fake Russian base and pretended to be cosmonauts. They actually all thought they were cosmonauts and going to space. You know, so it wouldn't be that much of a stretch to make Mars the next reality show where billions of people are tuning in to see this, you know, and they have worldwide auditions for people to go to Mars, and they could literally fake the whole thing, simulations, training, everything. The actors or the people they hire would completely think it's real, and they would send them off to Devon Island or some ridiculous place in the Australian outback or the Atacama Desert or something where there's ridiculously hot, and they would cloister them in a facility or a hab zone that they've created and state that they can only go outside during certain times, yada yada yada, when it's controlled environments, and they know where what the temperatures are going to be and the sun is going to be and things like that. We got somebody in here that asks a real flat earth question. RORMC asks, so where does the sun go when it goes below the horizon? Goes nowhere. It just goes out of your view. It's just not as high as they're telling you it is. It's not as large as they're telling you it is. It doesn't light up everything like they tell you it does. It's literally a localized illuminary body that just goes beyond your line of sight. It's pretty simple, really, once you understand how thick our atmosphere is, and our ability to see is it's a little less than 300 miles in a straight line. That's how thick our atmosphere is. There's 13 gases that make up our atmosphere. Then you add in dust, dirt, pollen, smoke, smog, humidity, water vapor, you name it. If it's in the air, it's going to obfuscate your vision. But people on the other side of the earth will see it rise at the same time. Correct. It's just floating over to their vantage point. You can replicate on your kitchen table with a light bulb. You can literally just hold a light bulb over a kitchen table, and you can put a couple of Lego figures on one side of the table and on the other side of the table, and just watch the light go, just rotate it around the edge of the table from one Lego guy to the next Lego guy. And that's exactly what the sun is doing. It does go further away, because if you were to, say you stand on the beach and you watch the sun go down, and then you pop up real quick, you've actually brought it back into view just at your little 6-foot vantage point. So extrapolate that further, and let's say you take a hot air balloon from the beach and rise up. The full sun will come back into view very easily. I've done this. There's a couple of large hotels in certain vacation places that have glass elevators where you can pull that trick where you can sit there in the lobby and wait for the sun to go down and then hit the top floor, and then as you rise up in the elevator fast enough, you can bring the sun back into view. Correct, Isa. The clock as we know it has been modeled after the sun and the moon movements. It's just nobody remembers that little fact. The horizon is merely your vantage point. It's as far as you can see. Remember, we can physically only see about 288 miles in any one direction. So once something gets beyond that, it just rises up to your viewpoint, your perspective, your horizon line. Take, for instance, somebody walking in a flat field. It looks like their feet go into the ground, and eventually it just looks like their shorts or their pants or their waist is walking on the ground. Yet we clearly know their body didn't sink past the horizon or dip into the earth. It's just how our perspective works. It's called ramping up, realistically. From wherever you are, there'll always be a ramp-up table, kind of like an inverted cone, so to speak, where your position is always the position of the inverted cone, and that cone extends out equal to the height of your eye line. And that is something that's very evident when you're out at sea. If you're floating out in a raft, is your vision can only go as high as your eyesight in the raft. You stand up in the raft, you can see a little further. If you go up on a ship, you can see even further still. You can go on a mast, you see further still. So that cone, that ramping up of your vision along the horizon has a limit. It's a good question, and it's really very simple to show, even on a small scale. It works, it works on both models, quite frankly. It works on a globe model, it works on a flat model. There's no disputing that each are explained equally as well. Yeah, they're called sextants. People have been using them since the early seafarer days. People can calculate the angle of the sun at any given point on Earth. What complicates the calculation is measuring for refraction, the amount of atmosphere the sun goes through at any given angle. So when you're looking at the sun at sunset, it's coming through more atmosphere, like more lensing. It's called atmospheric lensing. The atmosphere is thicker along the horizon, along the edges, than it is if you were just to look up at the noonday sun. Now, obviously everybody understands that. Even globe earthers understand that, because the noonday sun doesn't make the sun further away than it does at sunset, right? The horizon is an apparent line. All of the flat earth debunking videos do nothing to disprove flat earth or prove the spherical earth. Some do. Most are speculative in nature, I would agree. That's why I don't really rely on those kind of videos for the most part. What I do really appreciate Steve Torrance's channel. He has replicated all the star and planet positions based on JPL's data, and he's inputted into Cinema 4D, which is one of the most powerful 3D rendering programs. That takes into things like atmospheric refraction and things like that. And his models make plenty of sense. And in fact, if you watch his models from the beginning of his video feeds all the way to his more modern ones, you can see the problems they had when they were inputting all the JPL data of the stars and the rotation and things like that. That work until atmosphere was added. And then once atmosphere was added, then it all started to make sense. And it's not like the people who invented Cinema 4D are flat earthers. They're just inputting actual physics and data and things into their software so that creators in Hollywood and people in the industry can use the software to mimic and model in real time. For instance, like a lot of real-time physics, like simulating car crashes and things of that nature. So atmospheres is very much a well-known, quantifiable, measurable calculus that can be input into a computer model. You know, the Weather Channel uses very similar computer models to predict atmospheric conditions and where storms are going to be, and they're fairly accurate for the most part. They're about 90% accurate when they anticipate where things are going to end up and what they're going to look like. So computer modeling the atmosphere is well established in the scientific community as being good information source. I'm not sure I follow you when you say it's always the same debunked arguments, like ships over the curve. Who debunked ships going over a curve? You've never seen a ship curve to the left or the right. So until you can show me a ship curving on the left and the right of your viewpoint, then just bringing the ship back into view with a telephoto zoom lens or a telescope is proof enough to me. Plus, I understand the limits of our vision in the atmosphere. I understand how far we can see. I know all the gases that make up the atmosphere. I understand heat rising off the water and things of that nature. So that one I don't even see as remotely being debunked. Time zones are just... Okay, for one, if you ever looked at a time zone, it's completely man-made. It zigzags all over the place. But a time zone is technically a sweeping point from the center of the Earth, but like not center of the Earth, but from the North Pole. So time zones just match up with where the sun passes overhead. That's not even... I don't even see how people are using that as an argument for or against. It's nothing. God, Coriolis effect is absolutely nothing. I've disproven this over and over and over again because I have the sniper shooter manuals from both the Army and the Marines. They don't talk about Coriolis effect at all. The Coriolis effect, if you want to get down to it, it's the effect. It's an electromagnetism effect that the sun has as it travels over its sole lunar path, and there is... You can point to... I've got charts where I keep really good records of volcanic activities around what we call the Ring of Fire in the Pacific region, and almost always the cluster of volcanic activity always seems to be when the sun transitions over the when it crosses back over the imaginary Tropic of Cancer and Tropic of Capricorn, when it goes from one to the other and it starts its way back, which is always the vernal equinoxes. And you can see clusters of volcanic activity are greatly influenced by the sun. So you see lots of volcanic activity in April and May, and then September and October. So the Coriolis effect also influences the weather. So when the sun passes back and forth between those regions, you'll notice that if you want to use cyclones and hurricanes as examples, they only swirl in those directions on either side of the sun path, or the imaginary equator line that the sun will pass over. Yes, let me link you to Steve Torrance's channel. And you can look at his computer 3D models of how the sun and the moon and everything interact with one another. I haven't found anybody that can debunk them yet. Exactly. Frisbee golf is interesting. If you've ever played with a left-handed player or a right-handed player, yeah, no Coriolis effect there. Yeah, the reason why I study the volcanic activity is I'm greatly interested in Chile. Chile is on the Ring of Fire, and it happens to have several highly active volcanoes still to this day. And then, you follow that line up, and there's a few more active volcanoes up in Costa Rica, Honduras area as well. But they technically have volcano season in a way, and it has to do with the vernal equinoxes. And you can follow that around on the Ring of Fire all the way up to the Aleutian Islands in Alaska. They'll get volcanic activity followed all the way down through Japan, and their hot springs get hotter up on Mount Fuji. Even though Mount Fuji is technically dormant, and then followed all the way down to Indonesia where Krakatoa was, and things like that. You'll notice there's a distinct pattern between the sun's position and its crossings in the molten magma that's underneath. What drives the sun to travel circular? Well, I don't know, but as far as the best descriptor we have is that it is drawn to the magnetic center. We'll just for explanation's sake, let's say we live in an infinite plane, and there's a bunch of geothermal ponds, okay? And in the center of every geothermal pond, we'll say there's, a giant comet, a meteor, whatever, large magnetic something came and splashed down and basically melted the ice and rose up land masses, and it's magnetic. And through that magnetism, or that impact, it created what we have is basically the sun and the moon that circle around it. So there is kind of like how you spin around marbles in a frisbee. And so that's at least the best explanation that I've heard thus far, is that the sun and the moon travel around a fixed point based on known magnetic fields, the giant torus of the magnetic field that flows in and outwards. And that the sun and the moon would travel at the peak of that torus, like inverted upside down. There's a line at which a torus field arcs backwards, back towards its center, and then back out towards the exterior. And that's where the sun and the moon travel, is within that peak of that torus field. And we get the northern lights actually happen at around the 70-degree parallel, I believe it is. And that's where the torus field interacts with the Earth's atmosphere as it points down towards the center, and it's a ring. So you don't get aurora borealis above that line or below that line. It's all within an arc in that same area, and that's our electromagnetic, our field, so to speak. Which you can't actually have a magnetic field in the way they describe on a sphere. Another reason being why you can't have an electromagnetic or a magnetic center of the core of the Earth is because there is no known experiment that you can recreate here on Earth where you take molten iron and molten nickel, and a magnet will be attracted to them, or a magnet will, or even a compass will be attracted to molten swirling metal. But if that metal cools and the ferromagnetite in it aligns, it will become magnetic, but never at a molten state. For instance, another example, those little rocks and or beads you can get, they're called hematite. They're kind of polished dark silver stones. Sometimes they're magnetic. Well, you can make your own hematite magnetic by just putting it in the oven at 550 degrees, and it becomes magnetic. Likewise, you can also demagnetize it too. I think the sun is the main driver of everything we know, and that's why it's worshipped like a god. The moon, the planets, the stars, likewise personified. Well, of course, the oldest known religion is sun worship. If you want to worship anything, worship the sun, because you see it every day. It gives life. It provides warmth. It does all the things that we need it to do. So naturally, it's deified. Well, let me ask you this. And you say a moving object travels in a straight path unless it's accelerated. However, what do electrons and protons are doing? Are they traveling in a straight path? Or are they orbiting around an electromagnetic body? You can replicate what the sun and the moon are doing on a micro scale. For what we know they are, we don't know. I mean, maybe some people do. Maybe it is studied and it's just not talked about because we're stuck on this heliocentric model. But it's, there's plenty of people talking out their ass about what the sun actually is, but for some reason, none of them are very accurate models, except for it's a giant nuclear furnace, But even that's just textbook conjecture. It is electromagnetic in nature. There's no doubt about that. really loud. This guy's pretty brilliant. I don't know if you guys have heard of Eric Dollard, but I'll go ahead and put the link in the description here. You guys can watch that later. But there's a lot of really good videos on YouTube when referring to the sun. I would say Eric Dollard is an eccentric and probably on par in intelligence with Tesla. He's kind of become a hermit in these last few years. He feels so slighted by by having his work stolen and his workshop blown up and all kinds of stuff happening to him, but he seems to have a knowledge beyond. Well, here's another thing I forgot. I wanted to bring up something. If we all agree that the sun radiates heat, right? It's we'll just say radiation for lack of descriptors, because that's essentially what it is. The sun's heat interacts with your skin and it vibrates, and you feel that heat. Yet there's no heat between you and the sun. So if the sun really was in a vacuum of space, is there any condition in which you can replicate that here on Earth by taking a radiant heater, an infrared heater, and put it in a vacuum and then make that heat strike an object across the vacuum and get any heat off that? And the answer is no. Heat does not travel in a vacuum. So therefore, the sun has to be fairly localized in order for us to physically feel the heat of it. It can't travel in a vacuum. The sun's very interesting. I've looked at it with some welding glass before. It's definitely interesting. Alright guys, it's 5 a.m. here for me, and I should probably pretend to get ready for Monday work, and I'm gonna wrap this chat up unless somebody's got any other questions they'd like to ask.